Welcome back to Math 109, Plane Trigonometry. In this video, we're going to look at the reciprocal identities that we have. So if you recall in the last section, we derived the definition based on the angle formed by the x-axis, and then the line through the origin and some point, which we'll call xy. We're going to call the distance from the origin to xy r. So we have some trig identities that we're going to look at, but first things first, we want to review what the definition of a reciprocal is. We say that z and w are reciprocals if zw is equal to 1, which we could also write z equals 1 over w, or w is equal to 1 over z. So we're going to use what we learned in the last section. We're going to consider sine theta times cosecant theta. By definition, sine theta is y over r, and cosecant theta is r over y. I multiply those together, I get r times y over r times y, since multiplication of real numbers is commutative, which gives me 1. So that tells me that the sine of theta is equal to 1 over the cosecant of theta, and also the cosecant of theta is equal to 1 over the sine of theta. Similarly, we can look at cosine theta secant theta. If we recall, by definition, the cosine of theta is x over r, and then the secant of theta is r over x. Those multiply together, everything cancels out, I get 1. So that tells me the cosine of theta is equal to this 1 over the secant of theta, and the secant of theta is equal to 1 over the cosine of theta. Then the final pair that we have on this is the tangent of theta times the cotangent of theta. Tangent of theta, by definition, is y over x. And straight from the definition, the cotangent of theta is x over y. Again, everything cancels out, and I get 1. So I can say the tangent of theta is equal to 1 over the cotangent of theta, and the cotangent of theta is equal to 1 over the tangent of theta. Now, because of these nice properties, for much of the rest of the course, we're only going to talk about sine, cosine, and tangent, because we can apply these reciprocal properties to get the other one. So, in the next video, we're going to look at when the individual trig functions are positive.